Okay, so today we are going to begin section 2. And in section 2, we're actually going to use everything that we did in sections 3 and 4. And what we're going to do is we're going to learn how to graph polynomial functions of a higher degree. So we already know how to graph linear functions, and we learned how to graph quadratic functions. Now we're going to graph functions that have an exponent of maybe to the third power, to the fourth power. So this is what we're going to be doing today. Most of it is using prior knowledge. However, we do have a few vocabulary terms that we need to cover before we move on. So the first one is called the end behavior of our graph. And this is how our graph is going to look once we put it on our coordinate plane. So what we're going to be looking at is our leading term. So whatever exponent is on the first term of our polynomial, that's going to determine our end behavior. Now your polynomial must be put in order from the biggest exponent and then set it down decreasing. So if it's an odd degree, and what I mean by an odd degree is this exponent on the first term is an odd number. So for example, an x to the third power, an x to the fifth, x to the seventh, and so on. Could be any odd exponent. When this occurs, when it's an odd exponent, the polynomial will have opposite behavior at each end. So when it's a positive number in front, so when this number in front, this a, it's a positive number, then the graph on the left side, on the left, it's going to fall. And on the right of our graph, it's going to rise. So it's going in opposite directions. And we're going to see what this means. So we already know how it's going to behave on the ends. What we have to figure out is how it's going to wiggle in the middle. Now, if the a term or the number in front of your x to the third power or x to the fifth power, whatever odd exponent it is, if this number is negative, then my end behavior is going to flip. It's going to rise to the left, but fall to the right. So rise left, falls right. Be able to recognize the description of the end behavior and be able to recognize that it's rising to the left or falling to the right when the number in front of your x to the third power or x to the fifth power is negative. Now, if you have an even degree, so for example, if you have an x squared or an x to the fourth, x to the sixth, so on, if the number in front is positive, then it's going to take on the shape of the parabola, and it would be both ends are going up. So it's basically taking on the shape of the x squared graph. And remember, when you have a positive number in front of your x squared term, it's a positive person, so they're smiling. And then same thing here, if it's negative, both ends are going to point down. So if there's a negative number in front of this term that's raised to an even exponent, then it's going to be both endpoints are going to be going down. And we're going to see how we're going to use this end behavior when we go to graph. The next new piece of information is multiplicity, which is on the next slide. So let's see that. Now, the part here where it says zeros, this is the same thing that we've been doing in 3.3 and 3.4. We're going to find the zeros by either using our possible zeros, factors of the last term over the factors of the first term, and then guess and test till we find the one that gives us a remainder of 0. Or if you're allowed to use a graphing utility, you would key it in, find one of the rational zeros, and then begin your synthetic division to bring it down each time, bring it down a power until we can get something that's factorable. Remember, zeros are also known as roots or solutions. So if you're ever given a question on the test that we're going to take, or an SAT or an ACT or a PSAT. If it says find zeros, or if the question says find roots or find solutions, we're doing the same thing. They all mean the same thing. Now, every root or every zero that we find that's a real root, that is also an x-intercept. Now, if it ends up being imaginary, then it's not on the x-axis. So this is what we've already been doing, and we're going to do the exact same process that we did in 3.3 and 3.4. Now, here's where multiplicity comes in. What we're going to do is after we find our zeros, we're going to count how many times we see the same answer. And if it occurs an even number of times, then we would say that it has an even multiplicity. When we go to graph it, it's not going to cross the x-axis. It's going to touch it and then it's going to turn around. It's almost like a bounce. So what I mean by an even number, so let's say we were given a polynomial and it said find the zeros, and the zeros that you found were x equals 1, x equals 2, x equals 1 again, and x equals 3. Now, these two right here, x equals 2 and x equals 3, you see how you only see it one time? So when a root or a zero occurs one time, 1 is an odd number. So these two have an odd multiplicity. However, x equals 1 and x equals 2, I'm counting, there's two answers that have the same number. So this is the example of the even multiplicity, because 2 is an even number. And I have two answers that have x equals 1, 2 is an even number, so it has an even multiplicity. Again, when I graph it, it's going to come in and touch the x-axis at x equals 1, but it's not going to go through the x-axis. It's going to touch it, and then it's going to turn away. However, for the odd multiplicities, it's actually going to cross. So for these odd ones that occurred only one time, it's actually going to cross the x-axis at those zeros. And we're going to see what this means in the next example.
Wait, so if the odds cross, then what are the evens? They bounce, right?
Correct. So like, for example, let me just show you here. So like my zeros here were at 1, 2, 3. I had one at 1, 2, and 3. All right, so for the ones at 1, let's say your graph was coming in this way. It's going to come, it's going to touch the intercept of 1, 0, and then it's going to bounce back up. But for these two zeros, the x equals 2 and the x equals 3, it would actually cross through the x-axis when I make my graph. And depending on where the other point is, it's either going to be increasing or decreasing. We're going to see that. But when it only occurs once, it actually goes through the x-axis at that number. So let's actually try this. Let's go to the next example. We're given our polynomial. It wants us to find the end behavior, the zeros, and the multiplicity. Now, just to demonstrate, I keyed this into Desmos. I don't want you to key it into Desmos and then take the picture of this and then just put it in your homework. What I want to see now is the synthetic division, the factoring or the quadratic formula, and then you're going to describe, once you get those zeros, what kind of multiplicity each answer has. So let's first describe our end behavior. Notice my polynomial is in descending order, so it's got the x to the third as the largest exponent. So this is an odd exponent, So my end behavior for an odd exponent is going to be falling to the left, but rising to the right. And if you notice in the Desmos graph, what you're going to do is you're going to add this end behavior to your first zero that's farthest to the left, and then you're going to add the other side of the end behavior to the zero that's furthest to the right. And it falls and it rises. And we're going to see this. I'm going to do it by hand. So that's the end behavior. You would just show me with arrows. Now we have to find the zeros, which is exactly what we've been doing for the last couple nights of homework. Again, you can either, if you're not using a graphing utility, then what we would do is list the possible zeros. And my possible zeros, the last number is 8. So the factors of 8, 1 times 8 and 2 times 4 over the factors of the first, which is just 1. So if you were entering this in WebAssign, -1, 1, -2, 2, -4, 4, -8, 8. This is the list of possible zeros. Now, if you were not using a graphing utility, you'd have to start going through this list and doing synthetic division until you get a remainder of 0. Well, I went ahead, I keyed it into Desmos. I already know my zeros. I'm going to do synthetic division, and I'm going to do it using the -2. Now, you could also do it using the +2 because that's also a 0.
Wait, so for the homework, would you have wanted us to use a graphing utility or to have worked it out?
You can do that. You can go ahead and use your graphing utility, but now that I found one of the zeros, I want to see all this work now. Everybody with me? Okay. So
but
now
you don't have to show it for all the possible zeros, just the one that the one that shows on Desmos, just show the work for it.
Correct. I don't think it's asking you in the homework to list the possible zeros. I just quick glanced at the PDF. Just follow the directions. If it asks you to list them, then absolutely list them. If it does not say list possible zeros, then just start your problem with the 0 you're going to do synthetic with. Everybody good on that? All right, so let's go ahead and add the coefficients in. 1, 2, -4, -8. I'm going to bring down. I'm going to multiply. I'm going to add the column. I'm going to multiply again. I'm going to add the column, and I'm going to multiply again. I already knew that this is going to be a 0 because I looked at the graph. However, if we were guessing and testing from this list, it may not have worked. Now, if you knew that you got it from a graph and you were confident on what you inputted into the app, that you did not make any typos, then what you would do is go back and fix your problem. Because if you knew that you typed in the equation here correctly and you got the correct graph and then you did synthetic with +2 and you didn't get this 0, go back and rework the problem. You did something wrong. Now I'm going to add my letters back. Remainder, constant, x squared. This is all the work I want to see. So now x squared minus 4 equals 0. I now have the difference of two squares that I can factor. I could also add the 4 and do the square root method, but let's just go ahead and factor it. This factors into x plus 2, x minus 2. If it asks you to list the factors, also bring down the one that you just did synthetic division with. And if it asks to list factors, which I don't think it does, these would be the factors. Now, it wants zeros though. So let's solve each one for x. So set each 0 equal, well, I don't need parentheses. Each one equal to 0. Solve for x. Subtract 2. Add 2. Subtract 2. Now I have to identify the multiplicity. So I'm going to look and check out my answers. So you can see that -2, I've got 2 of them. So you would say that the 0 of -2 occurs twice, or occurs 2 times. So it has a multiplicity that's even, because 2 is an even number. Now, when we go to graph,
Miss Corey?
yes.
I'm confused because at the x squared minus 4 equals 0, why didn't you add 4 and then get the square root of both sides?
That's what I just said. I said you could also do the square root method.
But then wouldn't you get 2 positive zeros and 1 negative 0?
So if I move it over, remember I get plus and minus 2. So I would...
Right, so then how would you write that?
So for the zeros?
Yeah, like I'm confused.
So, all right, so if you did not use the factoring method, then you would have just gotten these 2 zeros, separate them. So you had these 2 plus this one. So you still get the same answer I did. -2 is -2 is still occurring 2 times. Everybody good? Okay. Let me erase the scribble here. Okay. So -2 has a multiplicity that's even because I have 2 of them. But then the 0 that equals +2, this one only occurs 1 time. 1 is an odd number, so this multiplicity is odd. Because 1 is an odd number. Now, the reason why I want to identify multiplicity, remember when it's odd, it's going to cross the x-axis at +2. But for this one, when it's the even multiplicity, it's going to touch the axis, the x-axis, at -2, and then it's going to turn around or turn away.
Do we have to write that in our homework tonight, like that part, the touch x-axis part?
No, this is just the explanation of why. What you're going to have to do in the homework is you have to tell me that it's the multiplicity is even for -2, and you have to tell me that for the 0 of +2, the multiplicity is odd. I'm just explaining why we're identifying even and odd multiplicity, because when it's odd, it crosses it, but when it's an even multiplicity, when you have the 0 occur more than once, it's going to touch and turn away. So let's go ahead.
So is that why?
Go ahead.
Is that why on the Desmos graph at 2 it just crosses and it doesn't go up and down?
Okay. So why? So what? Say that again.
No, I'm just asking. Is that why it crosses at the 2 because the 2 is odd?
Correct. And then at the -2, you see how it's the -2 occurred twice, so that's why it's the touch and turn.
Right.
Okay. So let's go ahead and graph this by hand without looking at Desmos. So now what we're going to do is we're going to take, and we're also going to find the y-intercept. Okay, so my y-intercept, remember you're going to set x equal to 0. And really, if you look at your function, here's my original equation. I'm going to plug in 0 for all the x's. But really, it's just that constant sitting at the end. But just let me show you the math behind it. So y equals 0 plus 0 minus 0 minus 8. So y equals -8. So your y-intercept is 0, -8. So shortcut, The y-intercept is always your constant down here. Now, let's go ahead and just quick sketch a graph by hand to see how it's going to compare to my Desmos graph. So if I go ahead.
So the constant is always the y-intercept?
Yes. When it's written like this, when your given polynomial is like this, yes. Now, if you're uncertain, plug in x equals 0. Okay, so now let me add in, I got a 1, 2, 1, 2. All right, so I have an x-intercept, or a 0 at -2, +2, and then I also have the y-intercept at -8. 1, 2, 3, 4, 5, 6, 7, 8. So then here's my y-intercept. All right, now let's add in the end behavior. So to the 0 that's at the far left, remember your end behavior is falling to the left, but rising to the right. So on the 0 that's all the way over to the left, put that end behavior there. And then the same thing for the right side. Now, what I need to do is I need to see how my graph is going to wiggle in between. Now, remember this -2 over here, remember it's not supposed to cross the x-axis because it's got a multiplicity that's even. So remember, this is going to touch and then it's going to turn down. Now, what I need to do is figure out, this one still goes down. So what I need to do is use my remainder theorem or just plug in a value of x to get another order pair. So I need to find another point in between the y-axis and that last 0. And the way that I find that additional order pair is I can either use the remainder theorem or I can just plug in an x to my original equation. The x value that I want to plug in is going to be x equals 1 because I want the order pair in this section. So I can do synthetic division using 1, and the remainder I get is my y value. So 1, 2, -4, -8. Bring down, multiply, add the column, multiply, add the column, multiply, and I get -1. So I can graph the order pair +1, -9. So I'm going to come down here one step further. So I know my graph now comes down and now it goes back up.
Did you get the 1 from looking at like Desmos and seeing the other x?
No, I knew that because I'm looking for an x value that's in between this point here and this point here. So this is my x value that's in between.
But so because it's in between, like let's say the graph was bigger and it wasn't landed on 2, like if it was landed on, I guess like 4 or something, you wouldn't pick 1?
You could. No, you could.
In between, so like 1 through 3 you would pick?
Exactly.
Oh, okay.
So if you look at Desmos over here, my graph looks pretty much like it. You know, granted it went down a little bit lower than 9, but I just want to see an approximation that you knew that the graph didn't hit that y-axis and then bounce back up. It had to continue going down a little bit. So that's how we're going to be graphing. So you're going to need to find additional points by either using synthetic. I could have also found my additional point by taking my original equation, x cubed plus 2x squared minus 4x minus 8, and then plugging in 1 here for x. And I can get the order pair this way. Honestly, the synthetic division is a lot easier. And then I would get 1 plus 2 minus 4 minus 8, 3 minus 4 minus 8, negative 1 minus 8, and I still get the same answer by plugging in a 1 into the equation. You can do it either way, but you need to show me the work. So you see how the synthetic seems like it's definitely a little bit simpler. All right, so here are the strategies. Graphing, again, determine the end behavior by looking at the exponent, see if it's even or odd. Find the zeros like we've been doing all along. Then determine their multiplicity, so that way you're going to know if where that 0 is, if it crosses the x-axis or not. Find the y-intercept, and then get your additional points. Let's try another one. So again, I'm going to key this into Desmos so I can figure out which 0 to use. If I were not using Desmos or a graphing utility, then you would make your list of possible zeros to know what numbers to use in your synthetic. So plus and minus 1, 2, 3, 3, and 6 over plus and minus 1. So negative 1, 1, negative 2, 2, negative 3, 3, negative 6, 6. These are the list of possible zeros. Now, because we're graphing, even if we started doing synthetic division and we didn't get the remainder of 0, we can still reserve that synthetic division problem, and that could end up being some of our additional points. So it wouldn't be a waste of time. But I went ahead and I already keyed it into Desmos. Let's go back here. So now let's do synthetic. Again, I said I'm going to use positive 1. So we already know our zeros are going to be the 1, the 3, and the negative 2. These are the ones that work. But let's go ahead and set up the division. 1, negative 2, negative 5, positive 6. Bring down. I'm going to multiply. I'm going to add the column. I'm going to multiply. I'm going to add the column. I'm going to multiply and add the column. I got a remainder of 0. So again, this is what I expected because I already knew it was a 0 from Desmos. Now what I need to do is add back in the variables. Remainder, constant, x squared. X squared minus x minus 6 equals 0. Now what I need to do is factor this. And the factors in negative 6 that give me negative 1 are going to be negative 3 and positive 2. If they, again, ask you to list, don't forget to turn that original factor that you did the synthetic with, don't forget to turn it into a factor. So these are the factors, but really we don't want factors, we want zeros because we're graphing. So set each of the factors equal to 0. We're going to calculate our zeros. X equals 1, add 3, x equals 3, subtract 2, x equals negative 2. These are my zeros. Notice each one, I only see them one time each, so all of them have a multiplicity that's odd. Yes.
Why did you choose 1 for the division problem?
I could have also chosen negative 2 and I could have chosen 3. It didn't matter.
So you can choose any?
I'm sorry?
So you can choose any?
Correct.
Okay.
And then, but if you chose a different number, let's say I did synthetic with negative 2, then I would have gotten a different equation here to factor.
Okay.
But it doesn't matter. You can choose either one.
All right, thank you.
You're welcome. All right, so they all have a multiplicity that's odd. And again, the multiplicity tells me that they're all going to cross the x-axis.
Do we have to put that part on the whole?
No. All you're doing is telling me multiplicity is odd. Good? All right, now let's find the y-intercept and our end behavior.
Oh, shoot.
What's wrong? Good? Okay, remember your y-intercept is the constant here. So my y-intercept is the ordered pair 0, 6. This has got an x to the third. So this tells me my end behavior is going to be falling to the left, but rising to the right. And again, be able to put that into words. So now let's graph the 3 zeros and the y-intercept and add in the end behavior. So let's go ahead. I'm going to
Wait,
add
what did you say the end behavior was again?
up here. It's falling left to the left, but it's rising to the right because it's going up on the right hand side.
Okay.
All right, let me add.
The first exponent.
Can you-
I'm sorry?
Can you go back down to the multiplicities?
All right, what was your question?
You look at the first exponent to find the end behavior, right?
Correct, yes. All right, so let's graph the zeros in blue. So on my x-axis, I'm going to put a point on 1. I'm going to put one on +3, on -2, and I'm also going to graph my y-intercept, which is at 6. Let's add in the end behavior. So on the very far left 0, the end behavior tells me it goes falling to the left, but rising to the right. Now I got to figure out how it's... I'm sorry?
I'm sorry. How did you get the 0,6? You plugged in 0 for all the x's in
Correct.
the equation?
Yes.
Okay.
All right, now we need to find points in between the zeros. So I need to find another point that's in between this 0 and the y-axis. So the easiest one for me to plug in is going to be -1. And again, I can do synthetic division. So I'm going to
Wait, I'm sorry. Can you repeat that part, please? Like, how come on this time you're on the negative side where you're for synthetic division?
Wherever your zeros end up, that's where you're looking for additional points in between. So I need to find, and let me erase this.
But why couldn't you just do like +2 since we're by the zeros?
I need to do that one also. So I need to find additional points that are in between this right in here, these two blue points, and then I also need to find additional point in between these two zeros.
So any additional points in between the zeros?
Correct. And more than likely, if you've got 3 zeros, you're going to be looking for at least two additional points. The more points you add, the more precise your graph is going to be. But if you want to get away with minimum, you just need to find one in between each of these zeros. So let's plug in 1. Now you can either plug it into the original or you can do synthetic division. Again, I'm going to do synthetic. So I'm going to plug in -1. I'm going to write down my coefficients. So the 1, the -2, the -5, and the 6. Bring down. I'm going to multiply. I'm going to add the column. I'm going to multiply. I'm going to add the column. I'm going to multiply and add the column. Again, this becomes the order pair, -1, 8. So I can come over here. Now it's going to go off the graph slightly, so it's up here. So this tells me that when I continue my graph here as it crosses the x-axis, it doesn't go right to that y-intercept. It goes up first, and then it comes down. And now it's going to come down to the 0. But now I need to know where it's going to, how far down it's going to go. And that's when I'm going to plug in the 2. So now I'm going to do synthetic with 2. 1, -2, -5, +6. Bring down, multiply, add the column, multiply, add the column, multiply, and I get -4. So my next order pair is 2, -4. So this tells me that I'm going to come down to here as I make my graph go down, and then it comes back up, and it completes it. Now, if we go to Desmos, see that you knew that it had to go down below, close to that point there. Now, every place that your graph turns, that's called a turning point. And the way that you can tell how many turning points it has is you take the exponent of the beginning, 3, and you subtract 1 from it. And my graph is going to have 2 turning points.
Wait, you take the leading exponent and subtract 1?
Correct. So my graph will turn 2 different times. So here's the first time it turns, and here's the second time it turns. So if you ever happen to get a standardized test question, I don't think it asks you for this in the homework, but if it asks you how many turning points are there, you just take the leading coefficient, the leading terms, exponent, and subtract 1 from it. And that's how many times your graph will turn.
Is there going to be one on our homework that's like example 7?
I don't know yet. I haven't looked exactly at all the problems in the homework.
Okay.
Is number 7 already factored for you? Yeah. See, this is easy. It's already done for you. You don't need to factor it. I know I only have 3 minutes. So what I'm going to be doing is I'm going to do more examples. I think what I'm going to do is I'm going to, and this is what the graph of that function should look like. So again, I'm going to take the zeros that Desmos found for me. I have one here at -2, another one at 1, and then another one at 3. Notice I only have one of each, so they all have a multiplicity of 1, and they're all crossing the x-axis at each of those zeros. So now I'm going to go back to my problem, and I'm going to do synthetic division, and I'm going to use 1. You could use 3, you could use -2. It doesn't matter. You're still going to get the same answers.
Sorry. You can't use a 6 because it's a y.
Correct. Right. We only want x-intercepts. The wrong way. Notice the lowest it got was really 2.12. I don't care that you have to look for the exact value where it actually hits the turning point. I just want to... Okay, so this is the next one that we're going to do. The equation is 2x cubed minus x squared minus 25x minus 12. So again, from Desmos, I can see my zeros are at -0.5, -3, +4, and then my y-intercept is down here at -12. But I'm going to go ahead and work through this on the next slide. So let's go back. So since I already found one of my rational zeros, I'm going to use the +4, and I'm going to go ahead and do synthetic division with it to break this down so it's quadratic. I'm going to go ahead and add in all of the coefficients, +2, -1, -25, -12. Bring down the first coefficient, multiply, add the column, multiply, add the column, multiply. And again, I already knew I was going to get a remainder of 0 because I saw 4 on the Desmos graph. Let me go ahead back in my variables. So 2x squared plus 7x plus 3 equals 0. Now, this is factorable, so I'm going to go ahead and factor it. It'll factor into 2x plus 1 and x plus 3. I'm also going to bring down the 4 that I got from Desmos, and these are the factors. Again, I'll set each factor equal to 0 and solve for x. I'm going to add 4, x equals 4, subtract 1, divide by 2, x equals negative 1/2, and then subtract 3, and x equals negative 3. Now, for my multiplicity, each one of my zeros only occurs one time. So occurs one time. So this tells me I have a multiplicity that's odd. So that tells me that it's going to cross the x-axis at each one of these zeros. So now let me go ahead and find my y-intercept and also my end behavior. It's an x cubed, so again, opposite directions, falling left, rising right. Here's my y-intercept. It'll be an order pair 0, 12. So let me go ahead and get these 3 zeros and the y-intercept on my graph, as well as my end behavior. So let me go ahead and graph positive 4, negative 3, and negative 1/2. Also graph the y-intercept. I'm going to make my graph go by 2s. So negative 2, and then 4, 6, 8, 10, negative 12 will be here. I'm going to add in the end behavior. Remember, it's falling to the left, rising to the right. Now I just have to find the additional points in between each of these zeros to see how high and how low my graph is going. So again, I'm going to look for a point, another additional order pair that's in between these 2 zeros. So I'm going to go ahead and choose negative 2. Again, I could have chosen negative 1. Either way, I'm still going to get another additional point in there. I'm going to use the same coefficients that I did over there for the 4 when I did the synthetic division. I'm going to bring down the first coefficient. I'm going to multiply. I'm going to add the column. I'm going to multiply again, add the column, multiply one more time, add the column, and I get 18. So my additional point is going to be negative 2, positive 18. So let me go ahead and add that to the graph. So again, just like I did below the x-axis, I'm going to make my graph go by 2s here. So 2, 4, 6, 8, 10, 12, 14. The top up here is going to be 14. So I'm going to have 18 go a little bit off. So negative 2 and then 18, I'll put it up here. So I can now connect up here to the 18. Then it's going to come down to the 0, which is at the negative half. I can have it come on down here to the y-intercept. And now I need to figure out, does it come back up or does it go down further? So let me go ahead and also pick an order pair in between the y-axis and this last 0 of positive 4. So let me go ahead and do synthetic division, and I'm going to use positive 2. So again, 2, negative 1, negative 25, negative 12. Bring down, multiply, add the column, multiply, add the column, multiply, add the column. So I'm now going to graph the order pair 2 comma negative 50. Well, obviously I'm not going to make it actually count 50 spaces down. So I know it's going to be somewhere way down here. Let's just put it here. It's going into my work here. So connect it here and then make it go up to the 0. So here is my graph of that function. So that completes that one. Let's go ahead and take a look at the next graph. So the next graph we're going to be graphing is the negative x cubed minus 8x squared minus 11x plus 20. So again, I've included the Desmos. Here are my zeros, -5, -4, +1, and then my y-intercept up here at 0, 20. So let's go ahead and do this by hand. I'm going to use, there is the graph. +1 in my synthetic division. Now let's go ahead and take a look at our end behavior. Notice this is a negative number in front of my x cubed. So my end behavior is going to rise to the left but fall to the right. So let's go ahead and do synthetic division, add in the coefficients. Bring down the first coefficient. I'm going to multiply, add the column. I'm going to multiply, add the column. I'm going to multiply, add the column. Again, I have a remainder of 0. Remainder constant, x squared. So negative x squared minus 9 minus 20 equals 0. I now have a quadratic equation that I can factor. I'm going to factor out a -1 because I do not want to have to factor a negative x squared. So let me just go ahead and flip all the signs. I now can factor this into x plus 4, x plus 5. I can also bring down the 1 here that I did in the synthetic. So let me go ahead and put -1, x minus 1, then the x plus 4, the x plus 5 equals 0. These are my factors. I can set them all equal to 0. X plus 5 equals 0. So add 1. X equals 1. Subtract 4. X equals -4. Subtract 5. X equals -5. So here are my 3 zeros. I can also find my y-intercept. It's up here. It's the order pair 0, 20. Again, I found that by plugging in zeros here, which makes all that go away, leaving me with just the 20. So now let's go ahead and get these 4 order pairs on the graph. So -5, -4, +1, and my y-intercept. So let me go ahead and again make my graph go by 2's. So obviously it's going to go way up here. So if I go by 2's, 2, 4, 6, 8, 10, 12, 14, 16, 18, we'll say it's up here by the arrow. So that's my 0, 20. So again, let's add in the end behavior. We saw that it's rising left, but falling right. So now I need to find some order pairs in between. Now, this one's kind of tight here. So in order to get an order pair in between, I'm going to need to plug in -4.5. So I'm going to set x equal to -4.5. And I could do my synthetic as a fraction, or I could do the decimal. Let me try it as -9/2. It might be easier. So again, put the coefficients. Bring down. -9/2 times -1 is going to give me positive 9 over 2. And then I'll subtract and get negative 7 over 2. Multiply 63 over 2. Add negative 11 plus 63 over 2 is 9 over 4. Multiply negative 171 over 8. I could change the 20 into 160 over 8, so I could subtract. Gives me negative 11 over 8. So this is my additional point, negative 9 over 2, negative 11 over 8. This is really negative 4.5 and negative 1.375. So I know it's kind of tiny. So it's going to be over here, probably about here. So my graph will come down here, and then it's going to come back up. Now let's see where it's going to go from there. So again, I'm going to look for an additional point in between here and the y-axis. So let me go ahead and plug in negative 1. So I'll do synthetic division with negative 1, negative 1, negative 8, negative 11, positive 20. Bring down. I'm going to multiply, add the column. I'm going to multiply, add the column, multiply, add the column. So negative 1 comma 24. Wow, it's going way off the graph, even above my y-axis, my y-intercept. So it's going to be, for the negative 1, it's going to be way up here, above the 20, so I can put it up here. So let me go ahead and connect my graph here. And then it can come down and touch the y-axis, and then it'll come down to the 0. So there is my graph. And again, if you go back and look at Desmos on the previous slide. So again, I found the zeros, the y-intercept. Also, each one of these, the multiplicity for each of the zeros here, it's got an odd multiplicity because each one only occurs one time. And notice at each one of the zeros, it crosses it. It doesn't do a bounce or a touch and turn. Okay, so the next function we need, or the next polynomial we need to graph, is x to the third minus 4x squared minus 2x plus 5. So let's go ahead and take a look at the Desmos graph. So let me go ahead and do synthetic division using positive 1. So 1, negative 4, negative 2, positive 5. Bring down the 1, multiply, add the column, multiply, add the column, multiply, remainder is 0. Remainder constant x squared. So x squared minus 3x minus 5 equals 0. There are not any factors of 5 that will give me 3. So this is where I need to do the quadratic formula. So in factored form, you would leave this. You could bring down the x minus 1, and that would be the factors. So let's go ahead and do quadratic formula here. So my a is 1, my b is negative 3, my c is negative 5. Opposite of b is 3. Negative 3 squared minus 4 times a times c, that's all under the square root, divided by 2 times a. So 3 plus or minus 9, and then negative 4 times 1 times negative 5 is positive 20. Add that. I get 29 over 2. So my 3 zeros are at x equals 1 from here. And then I have x equals 3 minus root 29 over 2. And x equals 3 plus 29 over 2. Now, let's go ahead and approximate the square root of 29. The square root of 29 is about 5.4. So let's go ahead and figure out where we need to place our 0. So 3 minus 5.4 divide by 2, and this will be approximately negative 1.2. Fix that. And then over here, 3 plus 5.4 divide by 2, approximately 4.2. So let me go ahead and put the 3 zeros on my graph. And again, this has a multiplicity that's odd because each one occurs only one time. So I'll go ahead and place them on the graph. So one at positive 1. And again, I'm going to approximate this. So it's about 1.2. Oh, this was negative 1. So positive 1, negative 1.2, and positive 4.2. I can also go up here. Let's get the y-intercept. It's positive 5. My end behavior is going to fall to the left, rise to the right. So let me add in 1, 2, 3, 4, 5. Here's my y-intercept. I can add in the end behavior. Goes down. This one goes up. And now let me look for additional points in between. So here I can just come up here. And then now what I need to do is find an additional point in between these two zeros. So I'm going to go ahead and plug in positive 3. Go ahead and put the coefficients, the 1, the negative 4, the negative 2, and the positive 5. Bring down, multiply, add the column, multiply, add the column, multiply, add the column. So 3 comma negative 10 is going to be my next point. So if I come down here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's just say it's around 1, 2, 3. We'll put it down here somewhere. Make it come down, connect, and there's your graph. And again, you can look at the Desmos. So again, we can see our zeros are located at positive 1. And then notice all the other zeros are these long decimals. So this tells me I'm going to have irrational roots here. I'm going to have some square roots. So I'm going to use my only rational root, the positive 1, to do synthetic division. This graph, and their graph is going by 2, so it looks a little different than mine, but it does have the same shape. So this I'm going to go ahead and post as part 1, and then I'm going to make a second video with the last examples from the notes, and that'll be labeled as 3.2 part 2.